Hello friends, welcome to my channel. Now let's continue looking at the stock buy and sell problem series. So continue on video for Leetcode 188. Here let's have a look at Leetcode 121. So in this problem, so here the allowed number of transactions is 1. So that's the connection of this problem with problem 188. So we're going to treat this problem as a special case of problem 188. So first, let's recall the interpretations in problem 188. So here, so TIK0 means that the maximum profit at the end of I state with at most k transactions with no stock at hand after taking all possible actions, so buy, sell, or do nothing. So TIK1 means the maximum profit at the end of the estate with at most k transactions with stock at hand and after taking possible actions. So here I is the days and k is the allowed transaction, the number of transactions. So 0 means no stock and 1 means with stock. So here we are using one indexing for the days. For example, I state is corresponding to the index I-1 in prices. So as in problem 188. So this is the interpretation of the DP table, the DP elements, and this is the DP update rule. So TIK0 equals this one. This means at day I, we do nothing because at day I-1, so we do not have stock. And or at day I-1, we have stock. We can choose to sell and gain some profit at day I. So this is the second item in the max function argument. So the equation 2 is TIK1. It means that the first term in the max means at day I, we can choose to rest or do nothing because at day I-1 we have stock. So or we can choose to buy stock. The reason is that at day I-1 we have no stock, so we buy. If we buy, actually we decrement the profit state. So notice here is k-1, and in this problem the maximum allowed number of transactions is 1. So the recursion relation given by star and double star is updated as this. So star and double star here. So in this, so we replace the k by 1, right? So in these two equations, essentially we have the two variables involved is TI0 and TI1, right? So in this case, actually here 0 corresponds to TI-1 and 1-1, and because we buy, so here is 0. But so this corresponds to no transaction. Its state is no stock, so this should be actually 0, right? Then this is nothing but the negative of the price at index I-1. So with that said, so we established the connection of the current problem with problem 188. So this problem is a special case corresponding to k equals 1. So with that said, now let's present two formats of solutions using DP. So first one, I'm going to use a DP table. In other words, we're going to use tabulation. So for this, first I'm going to track the length of prices. So then we are going to do DP table initialization. So DP initialization. I'm going to call the first DP table corresponding to this one as TI10. So it's going to be 0 times n plus 1. And then so TI11. So I'm going to use 0 times n plus 1. So because this no transaction case we have updated, so now let's look at the no stock case. So if no stock, so we're going to set TI I10. So 0 should be 0. So it's already set when we do the make the DP table. And then also consider TI11, so 0. So if we do not have stock, but we result at stock with having stock, so this is going to be float negative infinity. So this finishes the DP initialization. So next we're going to do the DP update. So DP update as in problem 188. So here we are going to use van indexing. So we're going to do for I and Y in enumerate. So let's see. So let's do this. So for I, Y in enumerate prices, and we are going to using the indexing starting from 1, right? So this way, let's do the update. So TI10. So at the I, so it's going to be the max. So here we do not have stock at the end of the I. So the possibility is that TI10 and the previous day. In other words, at the I we choose to rest, and then we have stock at the previous day. So that is TI11, right? At previous day, then we can choose to sell stock, that is plus Y, to get some profit Y. And then another DP table, that is TI11 I. So this is going to be we result with stock at the end of the I. So it's going to be the max of TI11 at the I minus 1. In other words, at the previous day we do have stock. So at the I we choose to rest. And then we're also going to have a situation that is so here we're going to use negative the price, and that is negative Y, corresponding to buy a stock. So this is the update. So finally, actually we just need to do the return. The return is nothing but TI10, so at -1. So with that said, let's first look at the special case. Yeah, it passes the special case. Now let's look at the generic case. Yeah, it passes the generic case. So next we are going to present another format, because here we are using ON space overall. But if we observe the two equations, there are only two variables involved. So let's write another format. So we are going to change this one to be version v1. And here what we are going to do is that we initialize TI10 to be 0 and TI11 to be negative infinity C. Then we are going to do the iteration. So we just need to use the stock price for Y in prices. And then we are going to update TI10. So the update actually can be very easily obtained. So first, so it's the maximum of its previous state, so I10, or so we sell a stock to gain some profit, that is TI, the previous state with stock, then plus the price, right? And then we update TI11, which is max of I11, in other words, the previous day, and then we're going to use negative Y, so as indicated by this equation. So after that, we just need to return TI10, so the last state, the final state of this variable. So this is essentially the same as the first version. So now let's look at some check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So that's the solution for problem 121. Please follow up to look at the video for the solution or explanation for problem 122. So in that problem, the k corresponds to infinity. So with that said, I guess that's about it for this video. Thank you.